So we're talking about multiplying matrices, and the key part of multiplying matrices is looking at the dimensions of the two matrices that you're trying to multiply. And then from there deciding, first of all, can the two matrices be multiplied? And if so, what is the product actually going to look like? Okay? Quick review of dimensions. Dimensions are written as M by N, right? Where M is the number of rows and N is the number of columns. Okay? And what we need to know is that in order to multiply matrices, we have some very specific rules that the dimensions have to follow. Let's say we want to multiply matrices A and B. Okay, here's A, and we want to multiply it times B. For the product, let's write it actually in terms of the way you see the product, for the product A, B. Okay? In order to make this work, here's what has to happen. The number of columns of A has to equal the number of rows of B. And that's how the dimension starts to make an impact, because basically, let's say A has dimensions M by N. In order to multiply, B has to have dimensions N by P, right? These two N have to be the same. If those are not the same, the two matrices cannot be multiplied. Okay? When you do the actual product, you get a resulting matrix C, a new matrix. Matrix C has dimensions M from A and P from B. Okay, so what's nice is you are going to know exactly what your matrix should look like, if you can do it. So before we even get started on how, let's just make sure we got can we do it or can we not do it. We've got 4 example problems for you. I'm going to do the first one with you. SR. Okay, looking up there, S has dimensions 3 by 3. R has dimensions 3 rows by 2 columns. Since the 3's are the same, yes, we can multiply this. The dimensions of the product SR will be 3 by 2. Okay? What I want you to do is I want you to give a try to the final 3. 2, 3, and 4, and see what you can make happen. Okay, let's check number 2. Number 2, R has dimensions 3 by 2. T has dimensions 3 by 2. Even though these matrices are the same size, this 2 and this 3 right here tell us no. ST, okay? ST, S is 3 by 3. T is 3 by 2. The 3's match. This is a yes. And as a result, the dimensions are going to be 3 by 2. Last one's a little bit different, but it's a little bit awesome. Okay? S squared. Looking at S squared, that means, really, S times S. Okay? And I don't have it up there anymore, but the dimensions of S were 3 by 3. These 3's are the same. Actually, there's lots of 3's up here, but the 2 middle 3's are the ones we care about. They're the same. So, yes, you can multiply them. The result is going to be a 3 by 3 square matrix. When the rows and the columns are the same, the matrix looks like a square, and it's called a square matrix. Okay? So now how do we actually multiply these things? That's what we need to talk about. Okay? Let's look at an example. I'm going to give you 2 matrices that can be multiplied. Okay? A is a matrix 0, 4, 9, negative 3, 3, 2. Okay? B is a matrix negative 2, 1, and 2, 3. Okay? So, oh shoot, I wrote that wrong. Shoot. My bad. Because these you can't actually multiply. So let me change B up a little bit. Okay? There we go. Sorry. Here's what I mean. Let's check it. 2 rows by 3 columns. What I had up there was originally B was 2 by 2. There's no way that would have worked. So with 3 rows by 2 columns, now we have plan. So our resulting matrix, AB, its dimensions are going to be 2 by 2. AB will be a 2 by 2 matrix. Okay? And AB has 4 different entries. Okay? It has 4 different entries to it. Because it's a 2 by 2, it makes sense that it should have 4, 2 rows, 2 columns, 4 spots to fill. Okay? This first spot, AB11, here's how we determine what that is. We look at the first row of A and the first column of B. Okay? And here's what we do with that. We multiply across and down and add. Okay? So we take 0 times -2 plus 4 times 1 plus 9 times 6. And all of that, whatever that equals, I'm going to need a lot of room, so I'm going to move it down. Whatever that equals is going to tell us what entry goes in for that 1, 1 spot. Okay? To get 1, 2, now I have plenty of room. To get 1, 2, I'm going to take the first row, but the second column. And whatever that product is, adding and multiplying as I go, is going to tell me what I get. So I'm going to do 0 times 2 plus 4 times 3 plus 9 times 4. Okay? Here's where these are coming from. I just want to draw your attention to it. As we look at this one, this 0 right here times this 2. This 4 times 3 and 9 times 4. So as we went all the way across here, each multiplication step comes from each individual piece of this row multiplied with each individual piece of the column. Okay? So AB21. Second row now, back to the first column. Okay? So we have -3 times -2 plus 3 times 1 plus 2 times 6. And notice you'll start to see a pattern. As you kind of look at this, look at how this -2 is always being used right here. Or this times 1, or times 6. Okay, just like we use 0, 4, and 9 from that row. Okay, and then let's just quickly figure out the last one. Now I'm showing a ton of steps. Most of you probably can do some of this in your head. But it's good for us to examine the steps. Okay? So, -3, 3, 2 times 2, 3, 4. So we got -3 times 2 plus 3 times 3 plus 2 times 4. Okay, so we're slowly working through this. That is a lot of steps here to figure out the product. But let's keep going. 0 times -2, well that's 0. 4 times 1 is 4, 9 times 6 is 54. So the first entry here, that 1, 1 entry, is going to be 58. So we're going to add those. Okay? 3 times -2 is 6, or -3 times -2 is 6, plus 3 plus 12, that's 21. 21. 0, 12, 36. That's 48. -6, 9, 8. That's 11. Your product here is this matrix. Okay? So after all of that, we were able to simplify it down to a 2 by 2 matrix. Now I want you to try. Both of these are products that can be done. Okay? And in fact, you already know what the dimension should be. SR, when you multiply those, should have dimensions 3 rows by 2 columns. Okay? And S3 should be 3 rows by 3 columns. Okay? So let's see what you can make happen. Okay, so let's check and see what you're able to come up with. S times R. Now, order matters. Order matters. So when we look at this, we're going to take the first column, first row of S times the first column of R. Okay, so we got negative 12 plus 0 plus 18. It's going to be 6. Okay. Then we're going to go second row of S with the first column of R. I'm going to work down this time so you can see a little bit different way. We got 40, 0, 36. That's going to be 76. Okay. And then the third one. Third row, still first column. 4 times 1 is 4. 0 times 2 is 0. So 4 plus 0 is 4. Plus 27, so that's 31. Okay, then we're going to go first row with our second column. Negative 3, so let's see, we got, oh, these are going to be ugly numbers. Negative 36, negative 54, and 30. So it's going to be negative 60. Second row, second column. 120 plus 30 plus 60 is 210. Holy cow. And third row, right? I'm living in the third row here, second column. Where my entry lives tells me what I'm supposed to multiply with. 12 minus 12 plus 45 is 45. Okay? So, hopefully you're able to get all those numbers. If you didn't totally get it, go back and look at every single one of your calculations. We kind of went through them quickly, but go back and check. Okay? Let's also check S2. Or maybe not S2, but S squared, right? S times itself. Here we go. So looking at information for that S squared, basically what we're doing here is we're doing S times itself. So we're taking the first row times the first column. So for example, just looking at this entry right here, that's first row times first column. Okay? I love writing them out right next to each other. Like, that's my favorite thing to do when I'm doing these. Because I find it helps me figure out what exactly I'm working with. I'm not going to take the time to write it out right now because I don't want this to get too long on you. But as you're doing these and solving these, it may be helpful to you to write them right next to each other. Okay? If we go back, right here, we could move this, not that blue circle, move B right next to A. And then we could go, okay, 0 times negative 2, 4 times 1, 9 times 6. 0 times negative 2, 4 times 1, 9 times 6. Okay? So what we're looking at here matches kind of what we're seeing up there. But as long as you remember to go across and down and kind of step it off, you're going to do just fine. Right here, just look at another example. We are living in the second row, third column. Second row of S, third column of S. 2 times 10, negative 5 times 4, 4 times 3. Okay? So walk it off, maybe trace it with your finger, whatever you have to do. Couple things to keep in mind. First of all, the dimensions matter. Right? We went and practiced what are the dimensions. Is it going to work? Is it not going to work? And the reason we got so particular about that was because then look at this. Or look at this. It tells you what your product matrix is going to look like. We knew that S and R were going to be 3 by 2. When we did this one, we knew we wanted a 3 by 2, 3 rows, 2 columns, and then we could just fill in spots. Right? Or S squared. It was going to be 3 by 3, so we could fill in rows and columns. We knew exactly we were going to do this 9 times. Okay, so keep track of those dimensions. They will be very, very important to you, especially as you go through all of these matrix multiplications.